Welcome to the Architecting and Sizing the SEP Implementation lesson. The objectives for the lesson are shown in the slide. This is the Architecture Components topic. The protection and management components are the primary Symantec endpoint protection environment building blocks. The Symantec Endpoint Protection Client provides the security and protection to the endpoint. Endpoints can include servers, desktops, embedded systems, and virtual systems. Features and protection vary by operating system. The Symantec Endpoint Protection Manager, or SEPM, manages all products and product components, simplifying administration and software distribution. The SEPM database stores the configuration data used to manage the Symantec Endpoint Protection clients. The content and reputation components provide the signature and risk assessment value. Without these components, SEP does not bring best-in-market protection. Administrators must have one content source. Live Update is the primary content provider hosted by Symantec on the Internet, which provides content update to all engines building the protection stack on the SEP client. An internal Live Update, or LUA server, allows for control of the hierarchy and architecture used to distribute content updates. The Group Update Provider, or GUP, is a function built into the SEP client that can be enabled through the Live Update policy. The GUP role is used to redistribute content from the SEPM clients that have good connection to the GUP, but poor connection to the SEPM. Insight provides a reputation score on binary executables for Windows and helps prevent false positives with virus and spyware or sonar convictions. Intelligent Threat Cloud Service, or ITCS, reduces resource and storage overhead by keeping the most relevant signatures locally and applying small updates when needed. These components are hosted on the Internet, and all SEP clients require access to this service to maintain optimum protection. This slide shows that policies are downloaded from the SEPM to clients, and that clients update logs to the SEPM for reporting. Endpoints need individual Internet access for optimum efficiency of features such as Sonar, Download Insight, and ITCS. In this slide, the GUP is a client like any other client, and that is why this slide shows the GUP communicating with Insight. Note, the GUP does not provide consolidated reputation scoring. In this slide, the red path indicates downloads using Live Update technology. The blue path indicates download using SEPM Delta technology. The number 1 circles show that content is downloaded from Symantec to a client, SEPM, or internal Live Update server. The number 2 circles show that content is ready for distribution to clients directly configured to download content from the SEPM, Group Update Provider in a remote geographic location, or a Live Update Distribution Center in a remote geographic location. The number 3 circles show you that content on a GUP and Live Update server is available to clients. The SEPM and GUP updates occur on heartbeat and plus or minus the time in a randomization window when configured. And Live Update updates occur on schedules or on demand by an administrator or user request. One or more SEPMs linked to a database is called a site. A SEPM with an embedded database is a site. An organization may contain single or multiple SEPM sites. A data center or geographic location is the physical place where your organization locates its business. This is the Architecture Constraints topic. Before you start to design your architecture, you must consider multiple facets of your organization and what Symantec Endpoint Protection services and benefits are needed. First, list the technical and non-technical requirements that SEP must fulfill. For example, protect the endpoint at all times with the latest content available. Alerts must be immediately sent to the security team when a threat is not properly cleaned. For compliance reasons, permanent access must be given to all incidents for the past year. You also have financial needs to consider. Small IT teams with basic training, a costly WAN, reduced bandwidth in some geographic locations, new hardware requirements to run the infrastructure. Your budget will help to qualify your needs. Although a typical setup per Symantec best practices is covered in this lesson, your environment is unique, and some changes to the standard architecture may be required. The key point is to understand why you need an adjustment and how it solves your issues. Geographic locations. You may have facilities and users located around the world, and legal requirements may force you to store logs in the country of origin. You may have a large IT team overseas, and your WAN is reaching its capacity. You may want to locate your primary site where your IT team is located. Administration. You may need to run an incident response team with a large number of users connecting to the SEPM console. Number of clients. SEP works with small businesses and with large multinational accounts. Depending on the number of clients in a particular geographic location, you may consider an alternative method of content distribution. External requirements. To comply with regulations, you may keep a year's worth of security-related logs. You may have a large workforce on the road and need to manage clients over the internet. The above constraints are referred to as field constraints. It is critical that you identify your constraints before designing the architecture. Content updates. The most important consideration is the efficient distribution of content. Content distribution has an impact on network bandwidth and on the resources used on the SEPM. The placement of SEPMs is a key aspect of the architecture, but this does not mean that multiple SEPMs are required to deliver content in a distributed environment. Other methods, such as group update providers or live update administration servers, can be more appropriate choices. Administration. Accessing reports and configuring the solution is an important part of maintaining a threat-free environment. The console is hosted on the SEPM, but can be accessed using three methods. Locally on the SEPM using an RDP connection, installing the Java console to remotely access the SEPM, or using the web console with a supported browser. In all cases, the SEPM and sites do not need to be multiplied to achieve remote management. Legal requirements. Some countries, such as Germany, require that personally identifiable logs generated in the country cannot cross the border. Therefore, at least one site must reside in the country. In some cases, this can lead to choose a multi-site environment. Other legal requirements can require keeping a long trail of logs, such as PCI for credit card processing. The SEPM may also require offline storage of these logs. While a replicated site with a larger database may be a solution, IT analytics may be an even better option because it adds data mining and custom reporting. Business continuity. If one or more SEPMs fail, the SEP client continues to store logs and maintain protection on the endpoint. In most cases, providing multiple SEPMs and fault-tolerant databases is enough. In larger organizations, entire data centers must be made fully redundant. In this case, additional SEPM sites may be required to adhere to company policy in case of major disasters such as floods, storms, volcanoes, earthquakes, and riots. Some general product limit guidelines are shown in the slide. These numbers are provided as a guideline only, as actual limits will vary according to hardware used, heartbeat frequency, content updates, and deployment methods. For more information, see the Symantec Endpoint Protection, Sizing and Scalability Best Practices White Paper. By defining these different considerations, you are able to prioritize what is important when designing architecture that meets the needs of your environment. This is the component placement topic. When considering the architecture, the main choice is based on how many servers and sites that you need to install before deploying your endpoints. There are two categories of architecture. Single site with one or more SEPMs linked to one database. Single site implementations can be small to very large. For the smallest implementation, a single SEPM with an embedded database requires no additional setup. For larger environments, 2 or more SEPMs, or up to 10, can be linked to one MS SQL database. One SEPM with a recommended hardware can handle a large number of clients. For most customers, using 2 SEPMs in a SEP environment is acceptable. A multiple sites architecture is where 2 or more databases are used. One SEPM on each site handles replication of settings, policies, and group structure, and optionally of content and logs as well. This setup is recommended for very large environments requiring site disaster recovery or for local log hosting due to legal requirements. Endpoint numbers listed are general guidelines only and not an indication of required server architecture. For example, you can have a very large, meaning greater than 50,000 endpoints, single-site customer environment with multiple SEPs and an MS SQL database cluster. Before you install a second site, you should decide whether or not multiple sites and replication are a good choice in your network. Setting up more than one site adds complexity that you may not need. Symantec Endpoint Protection Manager Help contains a useful guide to help you determine if multiple sites are right for your environment. You can access this guide and other information via the SEPM console, Help, Help Topics, Managing Sites, and Replication. The content distribution method varies depending on the operating system on which the client is installed. On the SEPM, the management server communicates at regular intervals with the client. The intervals are known as heartbeats. On heartbeat, the client publishes its current state and receives from the SEPM a new content update when necessary. On a GUP, this is the intermediary in an update chain. The GUP acts as a proxy for a remote site where the WAN link is relatively small. Any SEP client can become a GUP by policy configuration. The GUP centralizes all content requests for the remote branch and minimizes the amount of content downloaded from the SEPM. An internal live update server. This is a separate software installation that provides a centralized content repository for all platforms. The internal live update server can also work as an automated definition validation server where content is distributed first to a few systems for testing. This helps to ensure that no false positives occur on the production systems. After the validation is completed, the content is rolled out to the production network. In the Internet, each SEP client can be directed to retrieve content from Symantec servers on the Internet. This provides clients with content updates anywhere, anytime, and is especially important for keeping clients outside the corporate network up to date. This slide shows a single site that is comprised of the following: one site with 3 SEPMs and 1 SQL database, 14,000 endpoints worldwide, plus a few remote users logged on using a VPN. The data center is located in the United States. A branch office is located in Europe with 2,000 endpoints. Another branch office in Africa has 1,000 endpoints. From an administration view, this architecture is optimized for near real-time reporting. The policies are centrally stored in one database. The 3 SEPMs allow for hardware failure without loss of administration. In case of hardware or software failure on a SEPM, the clients connect to the remaining SEPMs and operate as normal. This is why Symantec recommends that you have more than one SEPM in a site with a Microsoft SQL backend. Equivalent failure with an embedded database results in the site being offline. Clients continue to be protected, however. Administration and content updates from GUPs or SEPMs are impossible. Logs accumulate locally on the clients and are sent up once the SEPM and database are back online. With an MS SQL backend, when the faulty SEPM comes back online, clients automatically fall back to their priority 1 servers. This results in an equal spread across the 3 SEPMs, if all 3 are configured as equal priority in the management server list. If the WAN link fails between the main site and geographic locations, clients in these regions continue to be protected. They can also receive updated content if the live update policy is configured for clients to use Symantec live update servers or internal live update servers. The only failure is a lack of reporting to the SEPM. After the link is reestablished, the clients upload the queued logs. This can generate a surge of network usage, but is controlled by a damper mechanism so that the volume does not overwhelm the WAN. Consider the following architecture: 3 geographic locations: United States with 10,000 endpoints, Europe with 2,000 endpoints, Africa with 1,000 endpoints. In addition, there is 1 site each in the United States and Europe. African clients are managed by the European site. Remote users can log on using VPN in the United States or Europe. Replication occurs every day at 2 a.m. Greenwich Mean Time, so that business operations in Europe are not impacted during business hours. By default, replication includes policies, group structure, and configuration. As an option, replication can also apply to logs and content. If a SEPM fails on one site, the clients for that site connect to the remaining SEPMs. If the SEPM is responsible for replication, the scheduled replication is lost and further delay in reporting is introduced. If the SQL backend fails, the clients continue to be protected and send their logs to a specific folder on the SEPM. When the SQL database resumes, the SEPM processes the log queue and inserts the missing logs into the database. The SEPM console is unavailable on the site where SQL is offline. Replication does not occur. In this example, if you need to perform administration on 10,000 clients in the United States, you must stop the SEPM services for the US-based SEPMs so that failover takes place, and the US clients become managed by the European SEPMs. Before triggering the failover, ensure that the WAN is not a bottleneck in your network to prevent further issues. After SQL is restored, you must restart services on the US SEPMs to restore normal operations. Finally, the next scheduled replication may be larger. This is because of potential configuration changes and extra logs generated during the failure. If the WAN link between the sites fails, then the clients report to their SEPMs and it is business as usual on both sites. The only negative point is that replication does not occur and a delay in configuration and log synchronization is introduced until the link and replication are reestablished. As shown in the previous examples, single sites are favored. In fact, Symantec IT chose a single site design for 20,000 endpoints worldwide. Single sites have simpler management and are very cost-effective. Because there is no replication, single sites provide consistent reporting with no delay. With the Let Clients Upload Critical Events feature enabled, clients can submit their security events immediately. Multiple sites give you geographic coverage and control over the WAN usage. Multiple sites also give you live backups of your environment. In conclusion, your design depends on your field constraints, needs, and the product limits. A single site with 3 SEPMs can support up to 150,000 endpoints, which is a very scalable solution. Some reasons to choose a single site are shown in the slide. Some reasons for choosing multiple sites can include legal constraints. Logs cannot leave the country, log retention for analysis, or when you must control when your WAN links are used, when large IT teams connect to the SEPM in multiple geographic locations, when you must have constant administration and reporting access, when merging 2 organizations, for example, a headquarters and a subsidiary, for replication, or perhaps local political reasons. To increase fault tolerance, the SQL database can be clustered. This reduces significantly the risk of downtime and keeps the advantages of a single site. This solution requires additional Microsoft licensing. The SEPM is a server that performs 3 major functions. It provides a console, it manages replication, and manages clients and distributes content. When planning a design, it is possible to dedicate a SEPM to a specific function, which is shown in the following slide. In this example, there are 140,000 clients split across 2 data centers. SEPM A is dedicated to reporting and administration. Clients do not connect to the SEPM. SEPMs B, E, and F share the load to manage 140,000 clients. The load is configured with multiple groups and management server lists. SEPMs C and D are dedicated to replication. The replication is configured to run each night after the database backup. Virtualization recommendations are shown in the slide. This is the Determining Client to SEPM Ratio topic. The frequency of communication is a polling interval called the heartbeat. Heartbeats are required for sending commands to clients, updating policies, and exchanging status information. You configure the Symantec Endpoint Protection clients to communicate with the Symantec Endpoint Protection Manager using either pull mode or push mode. Heartbeats exist in both communication modes, with each mode having advantages and disadvantages that you need to assess for each environment. By default, when you install the SEPM, pull mode and a heartbeat interval shown in the slide are applied. Symantec does not recommend push mode for large networks. In pull mode, the client connects to the management server according to the heartbeat polling interval. In push mode, the client establishes a persistent TCP connection to the management server, receiving immediate policy updates. The heartbeat interval is used for data uploads, such as client logs. As per the Symantec Endpoint Protection Sizing and Scalability Best Practices White Paper, for best performance, keep the database close to the management server and use pull mode. You can download the white paper from the link shown. This slide shows a SEPM to client ratio in pull mode. In general, the less frequent the heartbeat, the more clients a management server can support. You are not limited to a maximum number of clients that can connect to a particular management server. This is an example architecture from the Symantec Endpoint Protection, Sizing and Scalability Best Practices White Paper. In the following slide, you see data regarding how to set the heartbeat interval. This slide shows the controlled test environment used as a basis for this data. This slide shows the recommended heartbeat interval for 55,000 clients that are managed by 3 SEPMs. This is the content delivery topic. Symantec Endpoint Protection supports randomization of simultaneous content downloads to your Windows and Mac clients from the SEPM or GUPS. Randomization reduces peak network traffic and is on by default. A higher randomization value decreases the peak load on the SEPM, but delays content updates to client computers. A lower randomization value increases the peak load on the SEPM, but provides faster content delivery to client computers. To randomize content downloads from the SEPM or a GUP, you configure the download randomization settings on the Client's Group Name Policies tab, Settings Communications page. This setting has no effect on downloads from a Symantec or internal live update server. This slide shows content size, which grows over time. The content sizes in this slide were recorded on January 2017. Note that each content type has its own release schedule, which is why all protection engines on the SEP client do not report the same date. Content is usually downloaded from a Symantec live update server to the SEPM, and SEP clients retrieve their content from the SEPM. You can conserve bandwidth by offloading processing from the SEPM to one or more Windows clients that are configured as a Group Update Provider or GUP. After a GUP is created, the GUP can download content from the SEPM and distribute content to other Windows clients. If the GUP becomes unavailable, the clients can fail over to the SEPM or to another GUP. A GUP reduces duplicated content downloads between SEPM and remote offices, is less resource intensive, is useful for delivering content updates to clients that have limited access to the SEPM server, and does not distribute client product updates. Placing a GUP in the geographic location where the most users are located reduces the WAN usage for content delivery. Internal Live Update servers, installed with Live Update Administrator, provide flexible content distribution options that allow more granular control over WAN usage. The Live Update Administrator controls when and precisely what type of content is downloaded from Symantec, and it controls when and precisely what type of content is published to internal distribution sites, called distribution centers. A client's Live Update settings policy controls when the client downloads content from an internal distribution center, as well as which address and protocol to use. Internal Live Update distribution centers are categorized as test or production to provide a content validation mechanism. For validation, clients in a test group are assigned a Live Update settings policy configured to download content from a test distribution center. This allows administrators to make sure there are no unforeseen issues before publishing the content to production distribution centers for the rest of the clients to download. Live Update Administrator automatically installs a default test distribution center and a default production distribution center, and administrators can publish content to either type of site by schedule or manually as needed. This slide shows differences between a GUP and Live Update Administrator. This is the SEPM and database sizing best practices topic. Several factors can influence the type of database used, size of the database, and storage space that is required on the SEPM. These factors can include database maintenance settings, backup data requirements, number of content revisions to keep, log sizing and expiration times, content update sizes, application learning, the reliance on qualified DBAs or necessity to have more advanced maintenance available with a Microsoft SQL Server, multiple SEPs, which require a Microsoft SQL database, eliminating single point of failure with a Microsoft SQL database clustering. The following slides are examples of these settings and their impact on storage needs. This slide shows the embedded database size limitations and what occurs when that limit is reached. The MS SQL default database configuration slices the database into file groups per table type, for example, logs, content, and policies. Each file group has a default size of 20 gigabytes. When deploying a large environment, you must configure SQL so that the maximum size for the file groups matches available free space on the SQL Server's hard disk. Scheduled deletion of events ensures that log entries are deleted regularly to prevent your database from growing too large. Event compression consolidates multiple risk-found events into a single security event. Over time, and especially during a security event compression can help keep the database size within manageable limits. The data expiration settings affect how long data is kept in the database, which also affects how long that data can be reported. Ensure that you check on compliance and regulations about data retention for your environment when changing these settings. This slide shows the size of the various log data per 10,000 entries in megabytes. These sizes may vary from system to system. Logging options are configured by the administrator to optimize storage requirements and comply with company policies that control logged data retention. The following parameters are commonly used to control logging activity: maximum number of entries stored in the logs, and length of time by days to store log entries. This slide shows an example of threat event storage. This slide shows an example of log data statistics for a 26,825 node environment. True statistics vary from environment to environment. The following scenario shows the space that is required for a Symantec endpoint protection implementation with 26,466 clients. This example assumes the following metrics: an average of 15,000 viruses over 60 days, retention of 20,000 events for each log type, retention of 5 versions of each Symantec endpoint protection client, both 32-bit and 64-bit in English and French, and retention of 7 backups. This slide summarizes the lesson. For more information about the topics discussed in this lesson, refer to the resources listed on the slide, and remember to frequently check the Symantec support website.